Okay, today our topic is about the absolute functions. Okay, today our topic
Okay.
is about the absolute functions. Today our absolute function. So the absolute value function is a function. Basically this is the function. This is the function. Is a function that gives the distance from a number from 0 on the number line. Suppose that if we are making the graphical representation, suppose that we have the graph like this one. So if our location is here, so from this one, this is our origin, this is our origin, and with this, between this point, this is the our distance between the 2 points. So absolute function is basically gives us the distance of the number from 0 on the number line. Since since the distance is always positive, can't be negative, it is always positive, or it becomes 0. Suppose that you are sitting at point A and you are not moving from the point A. After an hour, when I check it, you are at the point A, so you are not covered any distance. That's why what I'm saying, distance is 0. So in our absolute function gives the distance between the 2 points, or from it is always distance from the origin to the given point. So it is positive, or it is 0, and it can't be the negative. Okay.
Yeah.
So, we can denote it like this, mod of x, and it defines as, so f of x is defines as x when x is greater than or equal to 0, and minus x when x is less than 0. So in mathematical format, we can define the absolute function is like this type of format: greater than or equal to 0. This is greater than or equal to 0, and this is less than 0. So this is negative side, and this is the our positive side. This is the our absolute functions. Okay.
Yeah.
Now I'm moving to the work examples. So this is your first work example. Look at here. For each following of the function, sketch y is equal to f of x and y is equal to f of x mod on the separate axis. So, okay, you can read it like mod are absolute of functions, and always f of minus x mod is r. This is minus f of x, this is always equal to positive of f of x, so are equal to positive of f x. It's mean absolute can give the negative function convert into the positive functions, can convert into the positive functions. Understand?
Yes, sir.
Okay, now I'm moving to the our first one problems. Look at here, y is equal to x minus 2, and our domain is what? Minus 2 is less than x is less than 0. As we already discussed in previous sessions, I'm telling you, mostly functions have the generic or general domain belongs to R. But when we are bound, when we have specific domain, then we are bound in specific domain, like this type of function. This is from starting from the minus 2, and this is ending at the 6. So you are putting x is equal to minus 2, so this gives y is equal to minus 2. So our order pair is minus 2 and minus 2, and when we are putting x is equal to minus 1, so y is equal to, this is minus 1 and minus 2 minus 3. So our order pair is what? Minus 1 minus 3. When we put x is equal to 0, because from this one to this thing, so our y is equal to minus 2. So our order pair is 0 and minus 2. And when we put x is equal to 1, so y is equal to what? 1 minus 2, this is equal to minus 1. So our order pair is 1 and minus 1. So what is the graphical representation of that function on the behalf of these points? On the behalf of these points, as you know, minus 2 and minus 2. So this is 0, this is minus 1, this is minus 2. X is minus 2 and y is minus 2. Suppose that our point is here. And when we set minus 1, this is minus 1 and this is minus 3. So this is at this type. So when we put x is equal to 0, we have x is equal to minus 2. So x is equal to 0 and y is equal to minus 1 minus 2. So our next one point is here. Okay. And after this, uh, after this we are putting the 1 and minus 1. So our this is function is minus 1 and 1. Got it? Got it?
Yes, sir.
See? Okay.
Yeah.
From this one, this is the all traditional method that already we discussed in previous sessions. So if we are drawing this one functions on the behalf of this one, so in the graphically, this is the linear function, and I'm telling you the linear function is the straight line. The linear function is gives us the straight line. So it gives us the straight line. Look at here on the behalf of this one, when we are setting 0 and 2, this gives us 0, and this is my x is equal to 0 and y is equal to minus 2. So this is at minus 2, and from this one, this is our x is equal to 0 and y is equal to minus 2. So from this one, our function is like this type of format. This is our single line or straight line function, because this is our linear function. Now I'm moving to the this one, y is equal to mod of x. So here what is given, y is equal to mod of x.
Yeah.
It's mean we take the mod of x minus 2. So when we reduce the mod, or when we vanish the mod, we have the two conditions. Already we discussed it. X is greater than or equal to 0 and x is less than 0. So x is greater than or equal to 2, and x is, so from this one, on the behalf of this one. So if I'm let x minus
Yes,
2,
sir.
let x
Yeah.
minus 2 is equal to 0. So x is equal to what? X is equal to 2. Okay, x is equal to 2. It's mean when we have x is greater than or equal to 0, so our function is what? X minus 2. But on the behalf of other side, when we have x is less than 0, so this is always what? This is the minus. So x minus 2, this becomes minus x, and this is plus 2. So I'm rearranging it to minus x. So this is 2 minus of x. So our f of x mod is equal to what? X minus 2 is greater than or equal to 0, and x is equal to, so look at here, what is x minus 2, and x minus 2 is greater than or equal to 2, and x minus 2. Here we have the construct our function into two parts. One is positive and one is our negative. But on the behalf of this one, this is, I'm writing the domain is general, that is already used in this function. But look at here, we have x minus 2 is equal to 0. So x is equal to 2. So our functions can be the converted up to 2 units. That's why our domain is always convert it here. So here I'm removing the 0 and I'm writing it 2, and here I'm writing it 2. And our critical point or our starting point is origin is 2. Why I set it equal to 2? Because on the behalf of this one, when I'm writing the x is greater than or equal to 0 and x is less than 0, it's a general or generic type. But this is can be the change on the behalf of our functions. And why I am saying, look at here, look at here. From this one, our functions move to the upside. The function behavior is positive. And from this side, look at here, the function is moved to the downside, and our function's behavior is changed from the negative side. That's why in this manner we have the 2 is greater than or equal to 0, 2 is greater than or equal to, and 2 is less than. Okay.
Yes, sir.
So is there any confusion regarding this one problem?
No, sir. No complete.
Okay. Same for the that one. Here I'm giving you the some clue point of this one functions. Look at here. Our x is square is equal to, so y is equal to what? Our x square minus 2. So this is minus 3 and less than x. X is less than 3. X is less than 3. Okay. Oh,
Yeah.
but before of this one, here I'm asking you some question. uh, you can do it. So what is the graphical representation of that functions, or how we can construct? So look at here, we have already find this type of function, we already find and their graphical representation. But here we are no we are trying this one, and how we can construct the functions, we are setting our to less than 2. So our f of x is equal to 2 minus x. Here x is less than 2, so we are putting x is equal to 1. So our x is equal to 1, so y is equal to 1, so our order pair is 1 and 1. And when we set our x is equal to 0, so y is equal to 2 minus 0, this is 2, so this is 0 and 2. And when we are putting our minus 1 and minus 2, and on the behalf of this one type, your function is starting from the 1 1. So look at here, and 0 and 2, x is equal to 0, so y is equal to 2. So on the behalf of this one, and when we have x is equal to minus 1, so y is equal to 2 minus 1, this is equal to plus 3. Minus into minus, this is the positive. So our this is minus 1 and this is 3. So look at here, our x is equal to minus 1 and y is equal to 3. So our graphical representation is like this type, and our graphical function is like this type. Okay.
Okay.
So on the next step, you can okay. Here I'm just for understanding, for your easiness, I'm making the function. I'm making the graph to the separate. I'm making the graph is separate. Look at here. First, I'm making the graphical representation of this one. Then I'm making the graphical representation of this one. But on the exam point of view, or when you are doing your practice, you can make the graph of these two functions at the same scale. Okay, got it?
Yeah.
So here I'm giving you this some little bit pro level tip. You are trying when you are making the graph of like this type, where you have the two or two more than functions. You can choose the different ball points. Suppose that you can make the graph of this one with the blue ball pen. Then you can use the green or black ball pen. And if you have the third one function, you can use the red ball pen. And in this manner, you can't interchange them, or you will not mix up them. Okay.
Yes, sir.
Okay, now we are moving to the next one problem. So our next one problem, as we already know, this is our what? This is our quadratic functions. And CK, quadratic functions graph is what type of the that function?
Parabola. Curve.
Parabola, or it is U-shaped like this type.
Yes.
So You know how we can construct the this one function graph. You know, we have the put the our dummy points, and we are bound in the dummy points to find out in between them. Okay.
Yeah.
So is there any need to solve it, or I'm moving to the absolute of that function?
There is, you need to put the absolute.
No, so I'm moving to the absolute of that function. So, sorry, this is our, so this is our y is equal to our function is what? We have the absolute functions. So y is equal to x square minus 2. X square minus 2. As we know, our x square minus 2 is equal to 0. So x square is equal to 2, and we reduce the square, and this is the plus minus 1, so x is equal to plus minus 2. As we already know, this is the quadratic function, and quadratic function is have the two roots. Here this is the two roots. So so on the behalf of this one, what I'm trying to write it, so this is 2 under root of 0 and minus 2 under root of 0. Why I am writing it like this? Because we have the two roots. We have the two roots. Okay. Is there any confusion?
No, sir, no confusion.
Okay, so I'm breaking the first one is what I'm trying to find the domain point where the function is behavior can be the converted, or where the behavior of that function is changed from positive to negative. So first of all, I'm finding these points. Now I'm making the function into the absolute value. So on the behalf of this one, y is equal to f of x of mod is equal to x square minus 2 of mod is equal to, look at here, this is the 2 minus x square, and this is our x square minus 2. X square minus 2 of under root is less than x, and x is less than 2 of under root, and here our mod of x is greater than or equal to 2 of under root. Look at here, what I'm trying to explain it. First of all, this one. Can you understand? Because look at here, we have x square minus 2, it will be the reduces plus minus 2. So in plus format, this is the x square minus 2 is as it is minus into x square minus 2. So it will be the converted into the minus of x square. This is the plus 2. So we modify it this one to minus x square. So can you understand it? How I'm
Yeah.
writing it? Okay. So this
Yeah.
is the as it is. This is as it is. But here we have the two roots. Look at here. This is the positive and this is the negative. So our negative function is belonging to the this one and this one. And how I am finding it? Look at here. We are already find the value of the x. So basically, value of the x is gives the output of that function. So output is sorry, value of x is our input. Value of our x is the input, and this is also called the domain. So it gives us the domain. On the behalf of this one, so I'm writing x mod is greater than or equal to 200 root. It's mean we can also write it it's mean x mod is greater than or equal to 200 root. So x is greater than or equal to plus minus 2 of under root, and this is more profitable situation of that one. This is okay, but this is the standard equation. Okay.
Yes.
Can can you understand it?
Yes, I understand.
Okay. After this, you are already know how to construct the graph of that functions, and how you can mix the two graph in a single scale. On a single scale already I'm explaining you. Okay.
Yes.
Okay, next one, our third one problem is basically this is related with our trigonometric function. So y is equal to cos of x is equal to 0 to 180 degree. So first of all, y is equal to our function is what? Our function is y is equal to cos of x, and our domain is 0 is less than or equal to x-axis less than or equal to 180 degree. So first of all, you can understand the graphs and their angles. Look at here. When we are moving from this one to this side, this is the 90 angle, and you are moving from 90 to and this is 180 angle. Each quadrant have the maximum 190 angle. So already I'm explaining you in previous sessions. Here we have the all positive.
Yes.
Here we have the all positive, even the our trigonometric ratios, six trigonometric, three are the direct, three are the of them they are inverses. Sine, cos, tan are all the positive. But here, we have the sine and their inverses, sine is inverses cosecant. These are the positive, and rest of them trigonometric ratios are negative. It's mean sine is positive, it's mean our cos is negative. So on the behalf of this one, here, here we have positive, and here we have the negative. Okay, this is just understanding you. I'm explaining you the statement of the problem. Okay, no, I'm trying to solve the this one equation. So this is basically this is the solution of that functions. So y is equal to uh, cos of x of mod. So cos of x of mod. So this is equal to, look at here, this is the cos of x, and cos of x is positive in first quadrant, so I'm writing it 0 is less than or x-axis less than or equal to 90 degree, and this is the minus cos of x, and this is the 90 degree is less than. So look at here, this is the 180 degree. So check it here. Here am I already explaining you. I'm already explained you. Here is our cos is negative, and here our cos is positive. So this is 0 to 90 is positive, and look at here, on the 0 it is always positive, on 90 it is always positive. But when we are starting from 90 to 80, so but when we are starting from 90 to 80, so after the 90 it will be the negative, but on the 90 it is the positive. So I'm writing 90 is less than x is less than or equal to 180. So when our function is from starting to that point, starting to that point, this is the 90 to 180. Here our function is negative. Okay,
Okay.
so is there any confusion?
No confusion, sir.
Okay, on the behalf of this one, you can construct the table like this type. So don't be panic. I'm making it our x. This is our cos of x. We have the like this type. When we are putting the 0 degree, cos 0 is equal to 1. And we have the standard of the angle 0, 30, 45, 60, and 90. So when we are cos 30, this gives us with the help of 0.866, and when we have the, if we are putting the 60, so cos 60 gives us the 0.5, or you are writing the half, and cos 90 it gives us 0, and same for the 120 angle. This gives us the at the when we are moving at this type at this time, so this is the minus 0.5 or minus half, and when we are 150, so this gives us at the 150 minus 0.866, and same for the 180 degree. 180 degree, this gives us the minus 1. Okay,
Yeah.
So is there any confusion regarding this one problem?
No, sir, no confusion at all.
Okay. Okay, then we are moving to the our next one exercise. So this is our exercise. Basically, this is our exercise 1.2. Exercise 1.2. And look at here. So f of x is equal to this one, and g of x is equal to this, h of x is equal to this, and we want to find the f of g of 2. Okay. No, we want
Yeah.
to find. So first of all, we want to find the f of g of x. So f of f is as it is. So g is what? G is our equal to x square. So we are replacing x with to the x square in the f function. So this is x 3 into x square. This is 2. So this gives us 3 of x square plus 2. Now our question is what into 2. So I am replacing it. F into g of 2 is equal to 3 into 2 of square plus 2. Look at here. 2 square is what? This is 4 and this is 2. This is equal to 12 plus 2 is equal to 14. Okay. Is there any confusion regarding this one problem?
No, sir, no confusion.
Okay. For your general knowledge, in advanced mathematics or in higher level mathematics, here we are writing f into g of x, but in advanced mathematics, we are writing like this one, and we are reading the form. In shortcut format, we are reading the form. This is not O, this is the mathematical representation. So this is defining between the combination or composition of the two functions. Okay, and same for when we are writing f into f of x. So this is equal to f into f, and in shortcut we read FOF. Okay, and when we are g into f of x, and we are writing it in advanced level, this is GOF. Okay, and the same for the g into g of x itself. So we are writing it g of g, GOG. Okay, okay, got it.
Yes.
So after this, look at here. For the this type of function, so we are writing f into g into h. In shortcut format, we are writing. We are already know f of x in shortcut format. We are writing f, and g of x in shortcut format. We are g, and h of x. We are writing it h. Okay. So from the first one problem, is there any confusion, or I'm moving to the next one problem?
Yes, sir. There's no confusion. Move on to the next problem.
Okay. Now we want to find the n f of x is equal to, look at here. This one and this one. No, I'm trying to, I will give you time. You can solve these problems. Okay. Don't, but first
Yes.
of them, I'm explaining it you. So I'm moving to that one function. This is the minus
Yes.
functions. So our basically we want to find first of all this one. We want to find the this one. So this is f into g of x is equal to what? This is equal to 4 minus x. 4 minus x. Now we are replacing 4 minus x in the f function, where we replace at the x. So this is 2 into 4 minus x. This is the plus 1, and this is the under root. Look at here. Uh, first we simplify it. So this is the 8 minus this is 2 of x, this is plus 1. So this is equal to, look at here, 8 plus 1, this is the 9 of minus 2 of x. and check it here. We are replacing with -4. We are replacing with -4. Why? It's our question demand. So this is f into g of -4. So this is 9 minus 2 into -4 and whole under root. Where I am replacing x is equal to, first of all, why I am replacing x is equal to -4, because it's our question demand. And now where we replace our x to the -4, here I am replacing x to the -4. So this is 9. So 2 multiplied by 4, this is 8. And look at here, this is minus, and this is minus, this is also a positive. So 9 plus 8 is equal to 17 of under root. Okay. So look at here. Is there any confusion?
No confusion, sir.
From the second part, which one part I'm doing it, or you feel this is very hard?
No, sir. I understand.
Okay, now we are moving to the third one problems. Third one problem is what? So in third one problems, I'm finding the hg of f of x. Here we have the three type of functions. Here we have the three type of functions. So h g into f of x. So h of g into f of x is equal to what? F of x is equal to, this is x plus 4. So basically, first we are finding the g of into, so first we are finding g into x plus 4. Then we will composite find with the h. So in g function, where is the g function? Our g function is this one. Our g function is this one, 2 of x square. So I'm replacing 2 of x square. So x plus 4 of whole square. So it gives 2 into x plus 4 square. So we have a plus b whole square. How we can open it? This is a square, this is b square, this is 2 of ab. So in this format, we are finding x square. This is the 4 of square. So this is 2ab, 2 into x of this is 4. Got it?
Yeah.
Okay. Then we are finding x square. This is the 16. So this is the 8 of x. And now we are multiplying this one. So 2 of x square. And here we multiply. This is 32 and this is our 16 of x. Now we rearrange it. So in rearrange format, 2 of x square. This is the 16 of x. And this is our 32. Okay. No, our question is not completed yet, because here we are just finding the like this type, and our demand is what? Our demand is this composition of the three functions. Here we are finding the composition of the two functions, composition of our two functions. Mm.
Yeah.
So our h function is what is equal to, h is equal to 1 over uh, 2 of x plus 1. Here I'm just writing it. So h is equal to 1 over 2 of x plus 1. So when we are finding h into, we are finding hg of x, hg into f of x. So we are replacing this one term on with respect to the x in the h function. So this is 1 over 2 into 2 of x square. This is the 16 of x plus this is 32, and this is our plus 1. Can you understand how I am write it? So basically,
Yeah.
I'm replacing I'm replacing this term with this one. Why I'm replacing it? Because our demand is composition of the three functions, composition of the three functions. So this is 1 over, look at here, 2 of 2, this is the 4 of x here, this is 32 of x, and this is our 64, this is plus 1. So on the behalf of this one, We are writing 4 of x here. This is 32 of x. So this is our 65. Okay.
Yes.
So any confusion regarding this one problem?
No, sir, no confusion.
Okay. Now we are moving to the fourth one problems. So I'm just taking I'm just pick it on the other side. Okay. Okay. So for
Okay.
each functions, find the inverse and the sketch of the graph y is equal to f of x and y is equal to f inverse on the same axis. Use the same scale on the both axes. Look at here. Again, our demand is what? On the same scale. So for the pro level tip you use, for the direct function you can make the graph with blue pen, and for the inverse function you can make your graph with the black pen.
Yes.
It differentiate between these two type of the functions. Okay. So
Okay.
look at here. As we already discussed it in previous sections, just for the go through, so I'm doing that one problem. So f of x is equal to 3 of x minus 1, and we want to find the f inverse. And you know y is equal to what? 3 of x minus 1. And what is our first step? We can separate x to the other side of the equation, and rest of that integers will be going to the y side, to the other side of the
Yeah.
equation. So this is minus 1 is this is the plus 1 is equal to 3 of x, and you know we are dividing on both sides by the 3. Why? We reduce the x. We want to reduce the 3x from 3x to x. We are moving. So this is the x is equal to y plus 1 over 3. Okay, y plus 1 over 3. And what is our last step? No, we are replace x to the y and y to the x. So what is our last one step? We are replacing our the function x from the y and y from the x. So this is our y is equal to what? X plus 1 over 3. So this is our inverse of that function. F inverse of x is equal to x plus 1 over 3. Okay, so what is the
Okay.
demand? For each of function, find the inverse and sketch the graph of the y is equal to f of x and inverse on the same axis. You know, as already we discussed it, we can put the dummy points, and here we have no specific domain. Here we have the no specifics. For our function is what? F of x is equal to, in general, 3 of x minus 1. And the examiner will give us this one function, so its domain is, so its domain is real number. So its domain is whole real number, or we are making the or we are making the real line, or we are making the real line. This is our 0, this side is positive, and this side is our negative. Okay.
Okay.
So no, we are not